the way, there's two different notations for arctan. I can write it as arctan x, or I can write it as tan inverse of x. We read this as tan inverse. There is a subtle difference between these two. They have slightly different domains as we define them in calculus. That is beyond the scope of what we usually talk about in 17A. So I'm not going to get into that. And in 17A, we're going to mostly consider these two things to be interchangeable. By the way, this is an implicit differentiation problem. Go us. So if I am staring at something that looks like y is equal to tan inverse of x, this is secretly tangent of y is equal to x. It is this question in disguise. And if my goal is to find dy dx, then when I look at this, I'm going to have to take the derivative implicitly. So let's go ahead and take that derivative implicitly. So if I take the derivative of tangent of something, and if you do not have your trig derivatives memorized, they are on that front formula sheet for the handout. The derivative of tangent of something is secant squared of that something. But I've got to remember either thinking about it as a chain rule or thinking about it as implicit differentiation. Because we took the derivative of something with a y, I've got to multiply by dy dx. With respect to x, the derivative of x is just 1. Which would mean that I would be looking at dy dx is equal to 1 divided by secant squared y. Two things are wrong with that. Well, one of them is not wrong. One of them is just less comfortable. I don't know about you all. I do not have my special angles memorized for any of the reciprocal trig functions, cosecant, cotangent, or secant. I prefer to live in the sine, tan, cosine world. So I'm going to take that 1 over secant and turn that back into a cosine, because 1 over secant is cosine. So this is the same as cosine squared y. There's no calculus happening there. That's a trig identity. Next up, I'm going to say, this is the part that's actually kind of wrong. We started off with a function of x. And now we've got our derivative that looks like it's a function of y. So we need to take this back to x's, and we're going to need trig to do that. The way I'm going to get this back to something in terms of x's is by looking at this right here and translating that into a graph or a picture. This tells me that my angle is y, because that's what we put inside of trig functions. We put angles inside of them. Now, if tangent of y is equal to x, then when I move over to this picture, tangent should be the opposite over the adjacent. So that tells me my opposite side is x, and my adjacent side had to be 1. So that this translates to this picture. Now that I've got my picture, I need to translate that back to what cosine of y is. So if I look at this picture, for cosine, I need the adjacent side and the hypotenuse. Well, we didn't have the hypotenuse before, but we can get it from Pythagorean theorem. So I'm going to get my hypotenuse by saying whatever it is, squared is equal to 1 squared plus x squared. So that hypotenuse side when I take the square root, is the square root of 1 plus x squared. I'm not going to bother with the square root because I don't need it. Because I need to know what cosine of y squared is. Cosine is the adjacent side over the hypotenuse. So technically my cosine part would look like 1 over the square root of 1 plus x squared, but I'm squaring that. So I would get 1 over 1 plus x squared.